Good morning, sir. This is Chandana from 3rd CSE A section. Today I am going to explain about role of entanglement in communication from the subject Introduction to Quantum Technologies and Applications. Uh, This is the introduction, the role of entanglement communication, locking connections. In this, first of all, entanglement. Entanglement plays a key role in quantum communication, enabling recurrent and constant correlations between instant particles. Here is the clear explanation about the entanglement. First of all, here we learn about what is quantum entanglement. Entanglement in quantum phenomenon where two or more particles become linked so that the state of any one instantly affects the state of other, no matter how they fall apart they are. For example, quantum entanglement means if two photons are entangled, one photon's polarization is measured as up, then other will be immediately down if they are separated by thousands of kilometers. And again, Albert Einstein famously called this Fourier action at a distance, as it is challenged classical physics notions of locality and realism in a profound way. Next, entanglement's unique property. This is non-local correlation, instantaneous knowledge. Measuring the property like speed or polarization of one entangled particle instantly reveals the corresponding state of its partner, regardless of their physical separation. Next, beyond classical limits. This correlation is a proven stronger and more predictable than correlation achievable through classical physics or shared hidden variables. Next, foundation and innovation. Here are the quantum key distribution, which is QKD, security through the entanglement. Unlike this QKD means quantum key distribution, entanglement ensures secure communication by detecting um, eavesdropping. Example E91 protocol uses a pair of entangled photons shared between two parties, which are Alice and Bob. Here, Alice is the receiver and Alice is the sender, and the Bob is the receiver. Alice sends the keys by encoding the message, and Bob decodes it with the same key using this. If the third person tries to interrupt the photons, the entanglement breaks and the distribution reveals the instruction. This guarantees an unbreakable encryption. Detection of intrusion was the core security feature is that any eavesdropping attempt fundamentally disturbs the fragile entangled state, immediately alerting the communicators to the presence of unauthorized listener. Here are the quantum teleportation. This means transferring qubit states from one to another. First here, Alice prepares the text and entangled through channel. Alice measures it and classical bit signs, and last Bob constructs it. This process requires three components: the state to be transferred, the classical communication channel, and pre-shared entanglement. Here the entanglement allows the transfer of quantum state from one place to another physically, sending the particle itself. This process is quantum teleportation. It uses a pair of entangled particles and classical communication. It ensures instant and lossless transmission of quantum information. Landmark experiment. China's Meskies satellite, 100 kilometers. Here, a record-breaking distance from entanglement distribution. This is a huge project in the entanglement. Here, long distant feet. The mucus satellite successfully demonstrated the distribution of entangled photon pairs of over a distance succeeding 1200 kilometers between the ground stations. Average disadvantages was utilizing the space-based transmissions helped the minimize signal attenuation and decoherence. Uh, Next, a global network is this achievement marks a crucial step forward in the ultimate goal of establishing a stable and network communications like this. Overcoming obstacles is the challenges in entanglement-based communication. Here, despite its promise, entanglement uh, entanglement-based communication at scale faces considerable technical fears. Decoherence and noise. Quantum states are highly sensitive. Quantum environmental noise rapidly causes decoherence regarding the fragile, entangled state, especially over long distances, extending the range. New infrastructure like quantum repeaters and entangled swapping techniques are being actively developed to maintain quantum signals and extend the transmission range. Next, scalability and error correction. Maintaining the stability of the qubits and controlling quantum gates and implementing robust quantum is an error correction, and it is small overcoming obstacles from the entanglement. First of all, entanglement beyond communication was computing and more. Entanglement is not a limited information to transfer, it is a vital resource of other quantum technologies. First of all, these have quantum sensing. It senses through the quantum system. Quantum simulation enables the scientists to model complex molecular interactions and materials that are reactable under classical supercomputers. At last, supercomputing. Hmm. This supercomputing works with a millions of speed than the normal computer. Future. It towards the quantum internet. The vision for a quantum internet is built entirely of harassing and disturbing quantum globally. Ultra secure networking, establishing quantum links between nodes and facilitate restrictedly secure and high speed information exchange. And global technique entanglement distribution with the one of the distribution and building scalable infrastructure, which is the deployment of quantum memory and overcome the distance limitations, and the cornerstone of next gen tech. Entanglement is recognized as the essential resource for the next generation of communication, distributed quantum computing. At last, I'm concluding my topic with this entanglement's transformative power. Redefining information, quantum entanglement fundamentally redefines how we think about sharing and securing information in the digital age, challenging limits from theoretical unbreakable encryption to the concept of teleportation. It pushes the boundaries of classical physics and engineering, at last paving the way. Continuous investment in the entanglement research is vital. Tomorrow's quantum communication revolution. Thank you, sir.